Srimati Ramakalyani to speak on Ganesa Daivajana's Upapattis on Lilavati. Srimati Ramakalyani has been teaching mathematics in some higher secondary school in Mylapore, Chennai. My association with her was when I did not know that I am associating with somebody. So he was student of my father, that's what I heard. So when he started his teaching career, she was one of the best students, that's what my father even today keeps telling. So it is hard to get students like her. So she has been a committed student as well as a committed teacher. And recently she has picked up interest after taking voluntary retirement from school to study Indian mathematics in great depth, and she is associated with KSRI, Uppaswamy Shastri Research Institute. She has registered for a PhD. Now I request Ramakalyani.
Shri Gurubhyo Namaha. Namasabhai Sabhapatibhyascha. Utpadakam yat pravadanti buddhehe adhishtitam satpurushena sankhyaha vyaktasya krishnasya tadeka bijam avyaktam isham ganitam cha vande. Bhaskara900 second commendably consolidated the paths of his predecessors such as Aryabhata, Sridhara and others with his own intelligence, and this clever work forms the first part of Siddhanta Shiromani, namely Lilavati. Arithmetic, combinations, series and pulverizers in algebra and geometry are included in this work, as without the knowledge of Patiganita, one cannot master Goladhyaya. Due to the genius and poetical elegance displayed by Bhaskara II, Lilavati became very popular compared to the earlier arithmetic works. It is easy to comprehend the intention of Bhaskara in entirety with the knowledge of a good commentary. One such erudite commentary is Buddhi Vilasini of Ganesa Daivajana. Ganesa Daivajana was born in 1507 AD to Keshava Daivajana, a famous astronomer and Lakshmi, at Nandigrama on the western seacoast. Ganesha's astronomical text called Grahalagavam is used in most parts of India even today. Ganesa Daivajana wrote this work at the age of 13. His other works are Lagutiti Chintamani, Brihatiti Chintamani, Vivaha Vrindavana Tika, Muhurta Tattva Tika, Shraddha Nirnaya, Parva Nirnaya, Buddhi Vilasini, and so on. Ganesha, like Bhaskara, is a poet as well as a mathematician. Buddhi Vilasini is written by him in 1545 AD. In this work, he gives verses with bandhas, quotes from various works on different subjects, provides grammatical notes, and so on. Above all this, Buddhi Vilasini is appreciated for the Upapattis employed in it for most of the rules and solutions of Lilavati. Ganesha also suggests his own rules and examples. Colebrook, in the preface of his translation to Lilavati, says that commentary of Ganesha, Buddhi Vilasini, is the best of all commentaries, comprising a copious exposition of the text with a demonstration of the rules. Professor Balachandra Rao, in his book Grahalagavam of Ganesa Daivajana, writes, Ganesha's commentary, Buddhi Vilasini on the Lilavati, is an extremely useful text to understand the rationales for the formulae and methods used by Bhaskara II and his predecessors. Ganesha gives his Upapattis in the form of logical explanations, algebraic proofs using Bijaganitam, demonstrations, and geometric proofs. An example for each type of Upapatti is considered here. Logical explanation is a convincing and relevant argument which can be analytical and reasonable in nature. Lilavati gives rules for operations with zero, yoge kam kshepasamam, vargado kam kha bhajito rashihi kaharaha syat, ka gunaha kam, ka gunaschintyascha seshavido, etc. Here, for the rule ka gunaha kam, which means a quantity multiplied by zero becomes zero, Ganesha gives logical explanation as follows. क गुणः कमिति त्रयेण गुणा 10 30 स्युः तेन एकोनेन गुणा 10 20 स्युः तेनापि एकोनेन गुणा 10 10 स्युः तेनापि एकोनेन गुणा 10 शून्यमेव भाव्याः यत एकोन गुणेन गुण्ये गुणिते गुण्यतुल्यमेव अपचीयते अत उक्तं कगुणः कमिति 3 multiplied by 10 is 30 3 less by 1 multiplied by 10 is 30 minus 10 20 that less by 1 multiplied by 10 is 10 and that also less by 1 that is 3 minus 3 multiplied by 10 is 0. If 1 less than the multiplier here is 3. If 1 less than the multiplier is multiplied by the multiplicand 10, then a quantity equal to the multiplicand, that is 10, is reduced from the product. Thus, every time 1 is reduced from 3, 10 is reduced from the product. Therefore, it is said 0 multiplied by a quantity is 0. Here Kriya Kramakari says, Kagunaha kena gunito rashihi punaha swayam shunyo bhavati and does not give Upapatti here. Ganesha utilizes Bijaganita rules to provide Upapatti and hence this is considered as algebraic proof. Bhaskara gives a Varga Karma problem as follows. Rashyor yayoho kriti viyoga yuti nireke मूलप्रदे प्रवद तौ मम मित्र यत्र क्लिश्यन्ति बीजगणिते पटवोपि मूढाः षोडोक्त बीजगणितं परिभावयन्तः. The problem here is to find two quantities x and y such that the sum of the squares of the quantities less 1, that is x square plus y square minus 1, and the difference of the two quantities less 1, that is y square minus x square minus 1, are square numbers. Bhaskara gives two solutions to the above problem in two rules. Ishtakriti rashtagunita veka dalita vibhajiteshtena ekaha syat asya kritihi dalita saikaparo rashihi rupam dviguneshta kritam seshtam prathamo athava paro rupam te yuti viyuti veke vargau syatam yayo rashyoho. The two solutions to find the pair of quantities are as follows. The square of an arbitrary number multiplied by 8 and lessened by 1, then halved and divided by the assumed number is one quantity. Its square, halved and added to 1 is the other. That is to say, if the assumed number is a, then the first solution is x is 1 by 2a into 8a square minus 1 and the second quantity y is half x square plus 1. Unity, second solution is unity divided by double an assumed number and added to that number is one quantity and unity is the other. If the assumed quantity is a, then y is 1 by 2a plus a and x is 1. When a is 1, the y value is 3 by 2 and when a is taken as 2, the y value is 9 by 4. The other quantity is always 1. Therefore, the solutions become 1 3 by 2, 1 9 by 4 and so on for taking different values of a. Ganesa gives Upapattis for both the solutions. Here the Upapatti for the second solution is considered. Dvitiya prakarasya Upapattihi. Yata kriti yuti viyutir veka mulada bhavet tata kalpitau rashi vargau yava ekam ru dve ru ekam atra dvitiya rashir moolam rupameva vekasya yogasya asya yava ekam ru dve varga prakritya moolam tatra ishtabhakto dvidha chepaha ityadina ishtabhaktena rupena ishtena jeshtam moolam त्रीन् अधः द्वे अयं प्रथमो राशिः एवमेतौ राशि त्रीण्यधः द्वे एकं द्विकेन इष्टेन ज्येष्ठमूलं नव अधः चत्वारि अयं प्रथमो राशिः द्वितीयः सर्वत्र द्वितीयो रूपमेव अत्र द्विकतुल्ये एव क्षेपे सति इष्टभक्तो द्विधा क्षेपः इत्यादिना ज्येष्ठमूले क्रियमाणे तुल्यगुणहारनाशे कृते सति रूपं द्विगुणे कृतम् इत्याद्युपपद्यते. If the Ganesha assumes two square quantities, a square plus 2 and 1, the root of the second quantity 1 is always 1. Here the x and y are two quantities such that x square plus y square minus 1, also minus x square plus y square minus 1 must yield square roots. In the one less than the difference of these quantities, that is minus x square plus y square minus 1. Minus x square is minus 1, y square is a square plus 2, minus 1 is minus 1, a square plus 2 minus 1, a square. This is a square by itself. The other one, where we say x square plus y square minus 1, the x square is 1 and y square as assumes a square plus 2 minus 1, we get a square plus 2. According to our problem, this a square plus 2 also should be a square. Therefore, we equate it to say b square. Therefore, the equation now becomes a square plus 2 is b square. Here he says Varga Prakritya Moolam. The roots of this can be found out by Varga Prakriti. Here he uses the Bijaganita rule. Ishta Bhakto Dvida Chepaha Ishte Nadhyo Dalikritaha Gunamula Kritaha Chadyo Krasvach Jeshte Kramatpade. Here, if the guna, that is the coefficient of x square, is a square number, divide the constant, that is Chepa, by an optional number and write the quotient in two places. The optional number is subtracted from one and added to the other. Divide both by 2. Then dividing the first one by root of the coefficient of the square term, the value of x is obtained, the value of the other remains the same. Here, the equation is a square plus 2 is b square and the coefficient of a square is 1, which is a perfect square. Therefore, we can assume an optional number. Let us assume the optional number also to be 1. The constant 2 is divided by the optional number 1. Therefore, we get the result 2. This 2 is kept in two places. With 1, 2, the 1 is subtracted from this first quantity and divided by 2 and also divided by root of the coefficient of the square term. So we get 1 by 2. And for the second quantity b, it is 1, the assumed number is added to 2 and divided by 2, we get 3 by 2. So this 2 is the result obtained by dividing the optional number. This 2 is in the rule itself. So this is called the Jeshta Moolam 3 by 2, which is the solution, and the second Moolam is always 1. The second root is always 1. Therefore, we get the solution 1 3 by 2. And we take the half as substituting for a, we get 4 as the two results. From 1 we assume subtract this, and thus we get 7 by 4 and 9 by 4. The Jeshta Moolam is 9 by 4. That is one root, and the other root is always 1. Thus we get 1 3 by 2 and 9 by 4 and these solutions. And assuming different values for this optional number, we get different solutions for the Varga Prakriti equation, that is a square plus 2 equal to b square. This is what Ganesha has given. And coming to demonstration or geometrical proofs, Bhaskara gives a rule for finding the area of a circle and finding the surface area and volume of a sphere. Vrittakshetra paridhi gunita vyasa padaha palam yat chunnam vede rupari paritaha kandukasyeva jalam golasyevam tadapicha palam prishtajam vyasa nignam shadbir bhaktam bhavati niyatam gola garbhe ganakyam. In a circle, a quarter of the diameter multiplied by the circumference is the area. That multiplied by 4 is the net all around the ball. The net all around the balls is nothing but the surface area, that is denoted like that. This surface area of the sphere multiplied by diameter and divided by 6 is the volume of the sphere. That is, area of the circle is half the diameter into circumference. That I denote diameter by d and circumference as c. Then the surface area of the sphere is, that is the area of the circle, half quarter of d into c, that multiplied by 4. Then volume of the sphere is 1/4 of the diameter into circumference, that multiplied by 4 into diameter by 6. And substituting d equal to 2r and also c equal to 2 pi r as we say today, these equations are the same as the equations we use for the area of the circle and surface area and volume of the sphere. Ganesha's Upapatti for the area of the circle. Atropapattihi vrittakshetrasya samam kandadvayam kritva tayoho kandayor yatepsitani suchyagrani shakalani yatasyuhu tata kande chitva prasarayet darshanam ete paraspara madhye sankramayya ayatam jayate tasya darshanam atra vyasardham eko bhujaha paridhyardham anyaha tayorghataha palam तदम अर्धमर्धेन गुणितं चतुर्थांशः स्यात् अतः परिधि गुणित व्यासपादः समवृत्त क्षेत्रफलं स्यात् इत्युपपन्नम्. The circular field is to be divided into two equal halves. Divide this into conical sections, as we call it as sectors nowadays, as many pieces as possible, and arrange them in such a way that a rectangle is formed. This is shown. See, this circle is divided into two halves, shown in two different colors. You can divide them into conical sections or sectors, as many of them as possible. And one half of the circle is shown up and the other half down. You arrange them in such a way that forms a rectangle. Here, one side is half the circumference because half of the circle is arranged. So the half the circumference is one side and the radius, that is half the diameter, becomes the other side of the rectangle. So area of the rectangle is length, that is half the circumference into half the diameter, and this area of the rectangle is same as the area of the circle. Therefore we get half the diameter and half the circumference as the area of the circle. As usual, substituting d equal to 2r and c equal to 2 pi r, we get the equation that we use now, pi r square. This is demonstrated even today in middle schools as an activity while introducing the area of the circle. Then Ganesha's Upapatti for the surface area of the sphere. Atha Golaprishtha Palotpattihi Golasya Paridhyardhena Tulya Vyasam Vartulam Vastradi Chitva Tena Vartula Vastrena Sagolordas Chedachadyate Tad Vastram Nivi Sadrisham Kinchit Sishyate Ato Nunam Tad Vastrapalam Ardha Golasya Prishtapalam Syat Vastrapalam tu Golasya Paridhi Gunita Vyasapadasya Sardha Dvigunitasya Asannam Bhavet Ato Vastrasya Kinchid Avasishtatvad Golasya Paridhi Gunita Vyasapadaha Dvigunita Eva Golarde Prishtapalam Kalpyate अतः चतुर्गुणितः परिधिगुणित व्यासपादः गोलपृष्ठफलं स्यात् अतः उक्तं फलं तच्छुण्णं वेदैरित्यादि. A circular cloth whose diameter is equal to half of the circumference of the sphere. See, if you take the small r as the radius of the sphere, then 2 pi r is the circumference of the base circle. Then the diameter is half of the circumference, therefore pi r. So the radius of the circle to be cut out is pi r by 2. That I take it as capital R. So a circular cloth whose diameter is equal to half of the circumference of the sphere is taken. Half the sphere is covered by this circular cloth. After covering the hemisphere, a small piece of cloth, just like a waist belt, is left. This extra cloth, subtracted from the circular cloth, is the surface area of the hemisphere. Area of the circular cloth is half d into c. The capital C denotes here the it's getting diameter of the capital C, the circumference of the circle, and small c, circumference of the sphere. So half d into c, substituting d equal to 2r and c equal to 2 pi r, and pi square nearly equal to 10, we get the area of the circular cloth is 5 by 2 pi r square, and the area of the remaining cloth is half pi r square. Area of the hemisphere is the subtracting the remaining cloth from the circle. Therefore, get 5 by 2 pi r square minus half pi r square, 2 pi r square. The area of the whole sphere is double this, 4 pi r square. Ganesha's Upapatti for the volume of the sphere. Atha Ganapalopapattihi Golasya Vyasardha Tulya Dhairgyani Suchyakarani Suchyagrani Chatushkona Dhairgyani Murdhni Hastatulya Vistratir Dhairgyani Kritani Kandhani Prishtapala Sankhyaneva Bhavanti. Evam Vidheka Kandasya Murdhni Chetrapalam Rupameva. Kanda Dhairgyam Vyasardham Saeva Vedaha. तेन गुणितं क्षेत्रफलं तस्य त्रयंशो घनफलं स्यात् क्षेत्रफलं वेदगुणं काते घनहस्तसंख्या स्यात् समकातफलत्रयंशः सूचीकाते फलं भवति इति वक्ष्यमाणत्वात् अतो व्यासषडंश एवैक खण्डस्य घनफलं स्यात् तत् पृष्ठफलगुणितं सर्वगोलस्य घनफलं जायते इति. The whole surface area of the sphere is divided into unit squares. Thus, for every square, there is one conical section made. Thus, there are 4 pi r square unit squares corresponding to each unit square, one thin conical section. And this has the surface area, that is the top area, as 1 unit square. This is divided into conical sections, and surface area is 1 unit square. And the depth of this conical section is nothing but the radius d by 2. And therefore, we get volume of one conical solid as the formula goes, base area into depth into 1 by 3. Volume of one conical section is base area 1 unit square, depth d by 2 into 1 by 3. So volume of 4 pi r square conical sections is 4 pi r square into this 2r by 6, which gives us 4 by 3 pi r cube, the formula we use today. And concluding, Buddhi Vilasini is a special kind of commentary to Lilavati. The commentaries like Lilavati Vivaranam work out the answers to the examples. The commentary Kriya Kramakari explains the rule and gives more answers to the algebraic problem discussed above, where multiple answers are possible. Ganesha Daivajana concentrates in his Buddhi Vilasani on providing Upapattis for the rules and solutions of Lilavati. Ganesha himself says aptly, Atropapatti Katane Akilasara Bhute Pashyantu Sugnya Kanaka Mama Buddhi Chitram. Here some of the Upapattis have been considered, which give an idea about this exceptional work. I have taken up this for my study. There are many more commentaries for Lilavati and other works which can be taken up by the researchers for study to unearth the hidden treasures. Thank you. Devagyan does not give that extra area how it is half pi r square. Therefore, I tried the way he suggested. So he says that you have to cut a circle which radius half the circumference. This has to be covered here. So I covered it. You see that little extra is remaining. If you cut it and physically if you measure it, it comes nearly to half pi r square. But exactly how, whether he has only arrived it through that is experimenting, or he derived a formula, that he has not suggested anything in his commentary. Thank you very much. Right.
Hello.
Thank you very much. You said in the Upapatti of the area of square, there comes the word darshanam 2 or 3 times.
Yeah, darshanam is shown.
Sorry?
Darshanam means it is shown. But
yeah, what does that mean?
In the commentary, probably, originally when the writer has written, he would have shown the figures. But now, that figures are not in the printed editions.
Yeah.
Therefore, we have to create our own figures.
Yeah, in other words, darshanam, do you agree whenever he says darshanam, that means it implies a diagram?
Yeah, he must have shown the diagram, yes.
Okay. Because I remember to have come across this expression in other commentaries also.
Yeah. But when it is afterwards written, that diagrams are omitted.
People while copying, they may have ignored later on. Do you find any manuscripts which have diagrams?
So far, no.
No. Then you said there are lots of quotations in Ganesha Daivajana's commentary. Did you make a list of these for your PhD work?
Yeah, I'm doing it. He has quoted from Chandra Shastra, from Varahamihira.
Yeah.
And,
No, I mean, you don't have to tell me. I'm just asking, have you made a list of all
he
these
has
citations?
quoted, and he makes his own verses, and even for prayer verses, he makes his own. And he gives verses with that is
Chitrabandha,
and
yes.
Khadgabandha and all.
That's right.
And,
Thank you very much.
So I am now concentrating on Upapattis. Thank you.
Actually, you answered both the questions I wanted to ask. Maybe I will still comment. There is only one printed edition of Buddhi Vilasini.
Yes.
It has lot of diagrams, actually. But there are diagrams Bhaskara is referring to. They are also called Darshanam. Bhaskara has his Vasana Bhashya on the top. So Darshanam appears many times there. So some are those diagrams in this printed, this Dattatreya Aptes edition, 1937. But whenever Ganesha is saying Darshanam, many times there is no figure in that
Even
printed
for this,
edition.
there is no figure from Ganesha.
So I think this calls for some new edition of the text. I am sure there will be manuscripts where the figure will also be there,
Yes, I am looking
if we
for
are able to
One Jiva
look.
only incomplete manuscript is there.
We will anyway discuss this,
we
what
have to-
manuscripts are
we
there.
have to
Okay.
find out.
Anyway, this is a general comment meant for others also, that we will perhaps have to look for a new edition of Buddhi Vilasini, because there are no figures in many places where Ganesha is saying Darshanam, there is no figure, whereas there are many figures with Vasana Bhashya. Other comment you have already, question I wanted to ask you have already answered. Did you do some practical experiment on
that's
the
what I
amount
said,
that is left out?
Yeah.
I think there is a very similar statement in Siddhanta Shiromani,
under
Goladhyaya.
Goladhyaya.
Also at the
Under
same,
Guna Koshadhyaya, Guna
the cloth is
Koshadhyaya, there
taken
under
and,
verses 50 to 57.
So the same point
in the
is
Vasana, he has this, and also he gives one more explanation that draw 24 circles with 196.
no, those are other proofs.
Yeah.
This is a practical kind of demonstration of 4 pi r.
There also he has not explained how it is for 2 pi r square. He also starts
So
there.
you have done that experiment. It's wonderful.
Yeah.
Thank you.
Thank you.
Anybody else?
Thus is the implication of the rationale. That is the meaning of the word darshan. Maybe. I'm just suggesting. Iti darshanam. Iti upapattehe darshanam. Thus the rationale is implied, or that is the implication.
No, it may be true, sir, but the where
Darshanam also occurs.
Kshetra darshan, yes, it is also possible.
yeah. But the place where it occurs, it implies that he is going to show the figure. But the end, if it is coming, you are correct.
Thank you.
Thank you, sir.
Thank the speaker.